the carbon dating model R equals to 1 over 10 to the 12 times e to the negative t divided by 8223. First of all, the 1 over 10 to the 12, when we were talking about exponential growth, exponential decay, I said that the number in front of the e is the initial population. In a carbon dating problem, the 1 over 10 to the 12 is the ratio of carbon 14 to carbon 12. So 1 carbon 14 is approximately equals to 10 to the 12 carbon 12. And then we have the exponential term. The rate is -1 divided by 8223. So since the rate is negative, this is an exponential decay. And then the t is time in year. So what is carbon 14? Carbon dating. Carbon dating is simply, so let's say an organic material die. So an organic material die, and then many years later, you found the material, you found the object, and then you use carbon dating to estimate the age of that object. So an object died many years ago, and then many years later, you found that object. You want to use carbon dating to find out the age of that object. Okay, so in this problem, I gave you a simple problem, the ratio of carbon 14 to carbon 12 in a piece of object. Just in, I don't want to give a specific like item, just an object. Is R equals to 1 over 8 to the 15. Of course, this capital R is different in different object. All right, so it's an object, a piece of paper, a piece of wood, whatever it is, the R is always different in every object, and then this capital R is always given in a problem. I have two questions. The first question is estimate the age of this object, and then after that estimate the ratio when the object is 5,000 years old. Okay, so how do you estimate the age? I gave you a capital R, so you have to write the capital R first. 1 divided by 8 to the 15, and then this capital R is equals to the carbon dating model, 1 over 10 to the 12, and then e to the negative t divided by 8223. I have to solve for t because I'm looking for time, age, time, right? You multiply the 10 to the 12 on both sides, then you have 10 to the 12 divided by 8 to the 15. That is equals to, I'm going to give myself a little bit of space to ln both sides, so I'm going to move this a little bit. E to the negative t divided by 8223. And then to carry the exponent down, I have to ln both sides. So let's go ahead and ln both sides. So ln the left and then ln the right to bring the exponent down. And then we have ln 10 to the 12. Do not approximate this yet. 8 to the 15 equals to, bring the exponent down. So we have t divided by 8223. And then times ln e is just equals to 1, and then you multiply both sides by negative 8223. So at the end of the day, so the time is equals to negative 8223, and then you multiply ln parenthesis 10 to the 12 divided by 8 to the 15, close parenthesis, and then what is that equal to according to the work I did? Okay, let me double check. T is negative 8223 times ln 10 to the 12, 8 to the 15. Yep, everything is right. So this one, I will approximate this to the nearest integer. Whatever I wrote in the previous line, that is the exact value. So this is approximately equals to 29,279 years old. All right. So you found an object, and then that is the ratio in that object, and then using carbon dating model, I estimate that the piece of object is that many years old. So this one is you have a ratio, and then you solve for time, and then the red question is, how about you have the time and you find the ratio? That one is way easier. So the way we do that is you just have to plug in t equals to 5,000. So that one is r equals to 1 over 10 to the 12, and then e to the negative 5,000 divided by 8223. And then you approximate this using using a calculator. So this one, when you do that, you will get a scientific notation. So this one r is equals to 5.44 times 10 to the negative 13. So this is in scientific notation. Another way to write this is 5.44 times 10 to the 13. So that is the ratio. And then I know the most challenging part is the calculator, right? So I also prepare that for you. I know exactly what you need in my video. So here is what I prepare for you. So the calculator part. So let's take a look. Let me just make it a little bit bigger. So for the first problem, I have negative A223 times ln 10 to the 12 divided by a to the 15. Type everything in one line and then just do one approximation. 292, 79. I add 1 from the A to this A. All right, and then the second problem, you estimate that, so negative 5,000 e to the negative 5,000 divided by A223, and then the whole thing divided by 10 to the 12. This one you get a scientific notation. So this e to the negative 13 is 10 to the negative 13. 10 to the negative 13. And then how about the decimal, 5.44? So the 5.44, that number must be between 1 and 10. I always use 2 decimal places. If you wish, you can just do a 5 times 10 to the 10 to the negative 13. So that will be 5 divided by 10 to the 13. You can do that as well. How many decimal places do you need to use? Read the problem. The problem should give you a very specific direction. All right, so that is the end of this video. If you like the way I explain carbon dating model, give this video a thumbs up. If you like the way I teach math, this is exactly what you are looking for. Give my channel a subscribe. Truly appreciate that. Trust me, it is worthwhile coming back to my channel to study more math. As always, I will see you all in the next video. Take care.